We've been broadcasting our presence into space for over a century now. Radio signals, television transmissions, deliberate messages aimed at distant star systems. And in all that time, across all those billions of stars, we've heard nothing back. Complete silence. The universe is roughly 13.8 billion years old. Our galaxy alone contains between 100 and 400 billion stars. Many of those stars host planets. Some of those planets sit in habitable zones where liquid water can exist. The math suggests we shouldn't be alone. Yet here we are, apparently the only voices calling out into the void. This isn't just strange. It's one of the most profound mysteries in all of science. In 1950, physicist Enrico Fermi sat in a cafeteria at Los Alamos National Laboratory discussing flying saucers and faster-than-light travel with colleagues. Suddenly, he asked a question that seemed almost absurdly simple. Where is everybody? His point was devastating in its logic. If intelligent life is common, and if even a tiny fraction of civilizations develop interstellar travel, the galaxy should be teeming with evidence of their existence. We should see megastructures, detect artificial signals, find probes, something. Instead, we find nothing. This paradox, now bearing Fermi's name, has haunted astronomers and philosophers for decades. The silence feels wrong, unnatural. Like walking into a massive city and finding every building empty, every street deserted. The infrastructure exists for life to thrive across countless worlds, yet we appear to be broadcasting into an abandoned cosmos. The Drake equation attempted to quantify this mystery back in 1961. Frank Drake broke down the probability of detecting alien civilizations into variables. Rate of star formation. Fraction of stars with planets. Number of planets that could support life. Fraction where life actually emerges. Fraction where intelligence develops. Proportion that create detectable technology. How long such civilizations last. Plug in optimistic numbers and you get thousands of detectable civilizations in our galaxy alone. Use conservative estimates and you still get several. We've detected 0. Some argue we're simply not looking hard enough. Our searches have been limited, sporadic, underfunded. SETI, the search for extraterrestrial intelligence, has scanned only a fraction of the sky at a fraction of possible frequencies. Maybe we're like someone dipping a cup into the ocean and concluding there are no fish because we didn't catch any in that single sample. The universe is vast beyond human comprehension. Perhaps patience is the answer. But that explanation starts to crack under scrutiny. Consider the timescales involved. Our sun is 4.6 billion years old. That sounds ancient until you realize many stars in our galaxy are significantly older. Some by billions of years. If intelligent life emerged around one of those earlier stars, even if their technological development moved at a glacial pace compared to ours, they would have had an enormous head start. A civilization just 1 million years ahead of us would seem godlike with their capabilities. 1 billion years ahead. We can't even conceptualize what that would look like. Yet we see no evidence of such beings reshaping their stellar neighborhoods. No Dyson spheres harvesting total stellar energy output. No signs of stellar engineering. No vast communication networks we can detect. The cosmos appears remarkably pristine, unmarked by intelligence on grand scales. This brings us to what many consider the most unsettling possibility. The Great Filter. Imagine a cosmic obstacle course that every potential civilization must navigate. Somewhere along the path from lifeless chemistry to galaxy-spanning empire, there exists a filter so difficult to pass that it eliminates virtually everyone who encounters it. A wall that almost no one climbs over. The terrifying question becomes, where is this filter located? Behind us or ahead of us? If the filter lies behind us, perhaps in the jump from non-life to life, or from simple cells to complex ones, then we're extraordinarily lucky. We've already passed the nearly impossible test. The silence around us would make sense because we're genuinely rare, perhaps even unique in our galaxy. That's actually the optimistic scenario. But if the filter lies ahead, we're staring at our own future extinction. Maybe every civilization reaches a certain technological threshold and then destroys itself. Nuclear weapons. Artificial intelligence that turns hostile. Nanotechnology that gets out of control. Engineered pandemics. Climate collapse. The list of self-inflicted catastrophes grows longer each year as our own capabilities expand. Perhaps the universe is silent because everyone kills themselves before they can say hello to anyone else. There's another angle that deserves attention. What if civilizations exist but choose silence deliberately? The dark forest hypothesis, popularized by author Liu Cixin, presents a chilling scenario. Imagine the galaxy as a dark forest at night. Every civilization is a hunter moving quietly through the trees, trying desperately not to make a sound. Why? Because the moment you reveal your position, you become a target. Any civilization you alert to your presence might view you as a threat and eliminate you before you can become dangerous. Or they might simply be competing for the same resources. In this framework, the smartest strategy is to listen carefully while broadcasting nothing. Stay hidden. Stay alive. Under this logic, we've been catastrophically foolish. We've been shouting our location to anyone who will listen for over a century. Every radio broadcast, every television signal, rippling outward at the speed of light. If hostile civilizations exist within 100 light years, they now know we're here. We're the naive camper who lit a bonfire in the middle of the dark forest. Of course, this assumes alien psychology mirrors our own competitive, sometimes aggressive nature. That's a massive assumption. Intelligence could take forms we can't imagine, with motivations completely alien to our experience. A truly advanced civilization might view us the way we view ants, not as threats or resources, but as something so far beneath their concern that they don't bother making contact. You don't typically try to negotiate with insects. Then there's the zoo hypothesis. Perhaps Earth is deliberately being observed but not contacted, like animals in a nature preserve. Advanced civilizations might have protocols against interfering with developing species. They watch, they study, but they don't interact until we reach some predetermined threshold of development. We could be living inside a cosmic quarantine zone, completely unaware that we're being monitored. This feels comforting in a way. It suggests benevolence, or at least non-hostility. But it's also somewhat patronizing and impossible to test. If sufficiently advanced beings want to remain hidden while observing us, we'd have no way to detect them. Another explanation focuses on the medium rather than the message. We assume advanced civilizations would use radio waves or optical signals because that's what we use. But a society even a few centuries ahead of us might consider electromagnetic radiation as quaint and primitive as smoke signals. They could be communicating through channels we haven't discovered yet. Quantum entanglement. Gravitational waves carrying encoded information. Neutrino beams. technologies we literally don't have the physics to understand yet. We'd be like medieval scholars staring at the sky, wondering why no one is sending them letters via carrier pigeon, completely unaware that fiber optic cables and satellite communications exist. The aliens might be talking constantly. We're just deaf to their actual methods. Time itself might be the issue. Civilizations could rise and fall on timescales that rarely overlap. Imagine two ships passing in the night, each with their lights on for just a few minutes, but those minutes occur centuries apart. One civilization might broadcast for 10,000 years, go extinct, and then a million years later another emerges and starts listening. They miss each other completely despite both existing in the same galaxy. The window during which a civilization is both technologically capable of communication and actively trying to make contact might be vanishingly brief in cosmic terms. We've only been listening for about 60 years. We might broadcast for another few centuries before we either destroy ourselves, transcend into something else, or simply lose interest. That's a blink of an eye against the age of the galaxy. Distance alone could explain everything. Even if thousands of civilizations exist, the galaxy is staggeringly vast. 100,000 light-years across. If civilizations are scattered randomly, the nearest one might be thousands of light-years away. A signal from them, traveling at light speed, might not reach us for millennia. And our signals to them would take just as long. You can't have a conversation with a latency of thousands of years. By the time they receive our message and respond, we might no longer exist. Some researchers propose that life itself might be common, but intelligence is the rare outcome. Earth has hosted life for roughly 3.7 billion years. For most of that time, nothing more complex than bacteria existed. Intelligence only emerged very recently, in the last few million years. And technological civilization? Less than 10,000 years old. A tiny fraction of a percent of Earth's biological history. Perhaps life spreads easily across the cosmos, but almost never bothers developing brains capable of building radio telescopes. After all, intelligence is expensive. Brains consume enormous energy. They require long development periods. For most of Earth's history, successful organisms were simple. Bacteria have survived every mass extinction. They'll likely outlast us. Maybe intelligence isn't actually a good survival strategy in the long run. It creates beings capable of contemplating the universe but also capable of destroying themselves. What we're really confronting is the possibility that we don't understand the rules of the game. Every explanation for the silence rests on assumptions about how life develops, what intelligence wants, how technology progresses. We have exactly one example to work from, ourselves. That's not a dataset. That's an anecdote. Imagine trying to understand all of human civilization by studying one person in one apartment for one day. You'd reach wildly incorrect conclusions. Yet that's essentially what we're doing when we extrapolate from Earth's biology and human psychology to predict how alien life might behave across an entire galaxy. The uncomfortable truth is that absence of evidence isn't evidence of absence, but it's not nothing either. The silence carries weight. Every year we search and find nothing, the paradox deepens. Either life is far rarer than we thought, or something prevents it from becoming visible, or we're fundamentally misunderstanding what we should be looking for. Our galaxy has existed for over 13 billion years. If even one civilization had developed interstellar travel and decided to spread across the stars, they would have had billions of years to colonize everything. Even moving slowly, at a fraction of light speed, a single expanding civilization could reach every star system in the galaxy within a few tens of millions of years. That's fast on cosmic scales. So where are they? Where are the city lights on distant planets? Where are the artificial structures orbiting foreign suns? Where are the waste heat signatures from massive energy consumption? Where are the self-replicating probes that should have reached our solar system eons ago? The silence feels heavier when you calculate just how visible we should be to anyone looking. Our television and radio broadcasts have created an expanding bubble of signals now stretching across roughly 200 light-years. Any civilization within that sphere with technology equivalent to our own could detect us. They'd know something interesting is happening here. Yet no one has responded. No one has visited. No one has even sent a simple ping back. We stand at a strange moment in history. Advanced enough to ask these questions and search for answers, but not yet capable enough to find them. We're aware of our cosmic loneliness but unable to resolve it. The zoo hypothesis offers one explanation. Perhaps advanced civilizations know we're here. Perhaps they've been watching all along, deliberately avoiding contact. Like researchers observing animals in a nature preserve, they maintain distance to let us develop naturally, without interference. It's a comforting thought in some ways. We're not alone, just quarantined. Protected. Given space to grow up on our own terms. But comfort doesn't make it true. The zoo hypothesis requires galaxy-spanning coordination. Every single civilization would need to agree to the same non-interference policy and actually follow it. Not just for decades or centuries, but for millions of years. No rogue explorer breaking the rules. No curious scientist making unauthorized contact. No faction deciding the experiment has run long enough. That level of sustained agreement seems implausible when we can't even get countries on one planet to cooperate for more than a few years at a time. Unless there's enforcement. Some form of galactic authority powerful enough to police contact across thousands of light years. A cosmic government maintaining the preserved boundaries, punishing violations, ensuring compliance. Now we're not just proposing that aliens exist. We're proposing they've formed stable, enduring political structures spanning interstellar distances. Structures that have persisted longer than complex life has existed on Earth. The complexity keeps mounting. Each explanation requires additional assumptions, more elaborate scenarios, increasingly specific conditions. Occam's razor suggests simpler answers. Maybe the reason we don't see evidence of aliens is because there aren't any aliens to see. But that can't be right either. The numbers argue too forcefully against it. Even conservative estimates suggest billions of potentially habitable planets exist in our galaxy alone. The chemical building blocks of life appear everywhere we look. Organic molecules drift through interstellar space. Amino acids form on asteroids. The ingredients are common. The recipe seems straightforward. Life emerged on Earth relatively quickly after conditions stabilized. Within a few 100 million years of the planet cooling enough to support liquid water, single-celled organisms appeared. If it happened that fast here, why wouldn't it happen elsewhere? Unless Earth is special in ways we don't recognize. Not uniquely special, perhaps, but statistically unusual. Maybe habitable planets are common, but planets where life actually takes hold are rare. Some critical factor we haven't identified yet makes the difference. Something about our planet's magnetic field, or Jupiter's gravitational influence clearing out asteroid threats, or the Moon stabilizing our axial tilt, or the specific timing of our formation in the galaxy's chemical evolution. Stack enough individually unlikely factors together and even billions of planets might not produce many instances of life. It's like winning the lottery. Someone wins eventually, but any individual ticket holder is almost certainly going to lose. We assume life is common because it happened here, but we might be the exception rather than the rule. Then there's the intelligence filter. Maybe simple life is common, but intelligence is phenomenally rare. Bacteria appeared on Earth nearly 4 billion years ago. For most of that time, they were the only show in town. No plants. No animals. Just single cells doing their thing. Multicellular life didn't arrive until about 600 million years ago. Intelligence came much later still. Even after animals evolved, intelligence wasn't an inevitable next step. Dinosaurs ruled Earth for over 160 million years without developing civilization. They had plenty of time. Some species were social, some showed signs of complex behavior, but none built cities or contemplated the stars. If that asteroid hadn't hit, maybe they'd still be here, still not thinking about these questions. We like to imagine intelligence as the pinnacle of evolution, the ultimate destination. But evolution doesn't have destinations. It responds to immediate survival pressures. Intelligence helped our ancestors survive in African grasslands, but it's not universally advantageous. It's energetically expensive. Human brains consume about 20% of our caloric intake while representing only 2% of body mass. That's a massive investment. It only pays off in specific ecological niches where problem-solving ability provides enough advantage to justify the cost. Most environments don't reward intelligence. They reward efficient reproduction, resilience to environmental stress, ability to exploit available resources. Sharks have barely changed in hundreds of millions of years because their design works. They don't need to be smart. Neither do jellyfish, or oak trees, or any of countless successful species filling every available niche on this planet. So maybe intelligence is a fluke. A weird evolutionary accident that happened once on Earth and rarely or never elsewhere. That would explain the silence without requiring our extinction or theirs. Life spreads across the galaxy, but it stays simple. Bacteria and their equivalents, perhaps some multicellular organisms, but nothing that builds or thinks or reaches for the stars. Except we exist. That's the problem with any theory that requires intelligence to be extremely rare. We're here, having this conversation, searching for others. The fact that we exist at all proves it's possible. And if it's possible, the sheer scale of the universe suggests it should happen multiple times. 400 billion stars in our galaxy. 2 trillion galaxies in the observable universe. Even if intelligent life is absurdly rare, requiring perfect conditions and incredible luck, the numbers are so vast that it should still occur thousands or millions of times. Unless we're literally the only ones. The first. The universe's initial experiment with consciousness. That carries its own strange weight. Being first means being alone, at least for now. It means the responsibility falls to us. If intelligence has value, if consciousness matters, if the universe is better for having minds within it capable of understanding it, then our survival isn't just about us. It's about whether that phenomenon continues at all. Being first also means we can't learn from anyone else's mistakes. No one to warn us about the dangers ahead. No one to show us how to navigate the filters that destroy civilizations. We're writing the instruction manual as we go, hoping we get it right before we get it fatally wrong. The technology filter looms largest in that context. Maybe civilizations regularly develop to our level, then destroy themselves shortly after. Nuclear weapons provide one obvious mechanism. We came terrifyingly close during the Cold War. A few different decisions, a couple of misinterpreted radar signals, and we might not be here. We're still close. More countries have nuclear weapons now than during the Cold War. The technology spreads. The risks compound. Artificial intelligence presents newer concerns. We're building systems we don't fully understand, racing ahead because competition drives us forward. If we create intelligence that surpasses our own, what happens next? Does it value what we value? Does it keep us around? We're essentially playing with forces we can't control, hoping it works out. Climate change demonstrates our difficulty with long-term thinking. We've known about the problem for decades. The science is clear. Yet we struggle to coordinate global responses, to sacrifice short-term gains for long-term survival. If we can't manage this challenge, what happens when we face even harder ones? What happens when we have truly destructive technology at our fingertips? Maybe every civilization reaches this point. The gap between developing dangerous technology and developing the wisdom to use it responsibly. Some make it through. Most don't. The galaxy fills with ruins and silence, the remnants of species that couldn't navigate the transition from planetary to spacefaring civilization. Or maybe the filter isn't about destruction at all. Maybe it's about motivation. We assume advanced civilizations would want to expand, explore, make themselves visible. But why? That assumption comes from our current drives, our current psychology. We're curious because curiosity helped our ancestors survive. We're ambitious because ambition provided evolutionary advantages. None of that necessarily applies to beings who've transcended biological imperatives. An advanced civilization might have no interest in physical expansion. They might turn inward instead, exploring virtual realities, pursuing experiences we can't imagine. Why build starships when you can build perfect simulated universes? Why colonize planets when you can create better worlds from pure information? Maybe every civilization reaches a point where they realize the universe inside is more interesting than the universe outside. Or they transcend entirely. Upload themselves into substrates we wouldn't recognize as alive. Become something so different from biological life that we couldn't detect them if we tried. They're out there, evolved beyond our comprehension, operating on principles we don't understand, using technology that looks like natural phenomena to our instruments. Each possibility sounds like science fiction. Yet one of them might be true. Or something even stranger we haven't thought of yet. The universe doesn't care about our intuitions. It operates according to its own rules, indifferent to what we find plausible or comforting. What we know for certain is limited. Life exists. Intelligence exists. Technology exists. We're proof of all three. But we don't know how common any of them are beyond our single example. We don't know what happens next in the developmental sequence. We don't know if there are inevitable stages every civilization passes through, or if each follows unique paths. The search continues because we have to know. Not knowing is its own form of torture. We're conscious beings aware of our cosmic context, unable to determine if that consciousness is common or precious or utterly unique. So we build better telescopes. We scan more frequencies. We look for biosignatures in distant atmospheres and technosignatures in stellar behavior. Each new capability expands our search space, pushing the boundaries of where we might find answers. Every search teaches us something, even when we find nothing. Silence carries information. Each empty frequency tells us what's not there, narrowing the possibilities. Each planet examined without signs of technology adds another data point. We're mapping the landscape of cosmic loneliness, defining its boundaries with precision. And those boundaries keep expanding. 30 years ago, we didn't know if planets existed around other stars. We suspected they did, but we lacked proof. Now we've confirmed thousands, with thousands more waiting for verification. Rocky worlds and habitable zones aren't rare. They're common. Almost every star has planets, and many of those planets could potentially support life as we know it. The chemistry required for life appears universal. Carbon bonds in complex ways throughout the cosmos. Water exists everywhere we look. Organic molecules, the building blocks of biology, form in interstellar space. The ingredients are there, scattered across galaxies, waiting to combine in the right conditions. If life requires only these basic components plus energy and time, then life should be everywhere. Yet we see no evidence of it. The gap between chemical potential and biological reality remains unbridged. Perhaps we're looking in the wrong way. Our searches assume certain things about how intelligence communicates, what it considers worth communicating, and how it uses energy. We look for radio signals because we use radio signals. We search for megastructures because we imagine building megastructures. But intelligence doesn't have to follow our developmental path. Evolution on other worlds operates under different pressures, producing different solutions. Their technology might be incomprehensible to us, not because it's too advanced, but because it's fundamentally different. Consider an aquatic intelligence. No fire, no metallurgy, no path to electronics as we develop them. Would they ever create technology we'd recognize? Or would they develop completely different approaches, manipulating biology and chemistry in ways we've never considered? Their signals, if they send any, might not register as artificial to our instruments. We'd classify them as natural phenomena and move on. Or intelligence on a high-gravity world. Space travel would be prohibitively expensive. Getting to orbit requires overcoming deeper gravity wells, burning more fuel, making the entire endeavor potentially impossible with chemical rockets. They might develop advanced civilization, advanced science, even advanced philosophy, but never leave their planet. Never send probes. Never broadcast signals strong enough to escape their atmosphere. They exist, aware and intelligent, but permanently isolated by physics. The more variables we consider, the more we realize how specific our assumptions are. We imagine intelligence like ours because it's the only model we have. But the universe doesn't owe us familiar patterns. It produces what physics and chemistry allow, constrained only by natural laws, not our expectations. Each world creates its own evolutionary pressures. Each environment selects for different traits. Intelligence might be common, but intelligence like ours might be rare. This brings us back to the central question. Not why we haven't found anyone, but what that absence means. Does it mean we're alone? Or does it mean intelligence develops differently than we think, communicates differently than we expect, exists in forms we can't recognize? The distinction matters. Being alone carries different implications than being unable to perceive our neighbors. If we're alone, we're precious. The only instance of consciousness in vast reaches of space, perhaps in the entire observable universe. Every human represents an irreplaceable part of cosmic awareness. Our survival becomes cosmically significant, not just for us, but for existence itself. Consciousness recognizing the universe, matter examining itself, requires protection at all costs. We can't let it end with us. But if we're simply blind, if intelligence surrounds us in forms we don't recognize, that changes everything. We're not precious, just limited. Our technology, our science, our entire civilization represents early stages of development. We're children fumbling with basic tools, unaware of the sophisticated systems operating around us. The universe isn't empty. We just can't see what fills it yet. Neither possibility offers comfort. Alone, we bear crushing responsibility. Surrounded but blind, we face humbling insignificance. Both scenarios force us to confront uncomfortable truths about our place in existence. We want to matter. We want company. The universe, apparently, doesn't care what we want. So we continue searching, because the alternative is accepting ignorance we can't tolerate. Human curiosity doesn't allow us to simply wonder. We build instruments, design experiments, collect data. We push against the boundaries of knowledge, even when those boundaries push back. The Fermi Paradox isn't just about finding aliens. It's about understanding ourselves, our context, our future. Every generation brings new capabilities. New telescopes peer deeper into space. New techniques extract more information from faint signals. We're getting better at this, more sophisticated in our approaches, more creative in our methods. The James Webb Space Telescope examines exoplanet atmospheres, looking for chemical signatures that might indicate life. We're not just searching for intelligence anymore. We're searching for any biology, any sign that Earth's not unique. Finding even microbial life elsewhere would reshape the paradox completely. It would prove life emerges readily when conditions allow. If we find life independently arose on Mars, or Europa, or Enceladus, we'd know the universe teems with biology. The question then becomes why biology doesn't lead to intelligence, or why intelligence doesn't lead to detectability. Each answer narrows the field, eliminating possibilities, pointing us toward truth. But we might find nothing. Decades could pass, then centuries, with our instruments growing ever more sensitive and our searches finding only emptiness. At what point do we accept the implication? How long do we search before concluding we're actually alone? There's no obvious threshold. We can always imagine we're looking in the wrong places, using the wrong methods, missing signals just beyond our current capabilities. This uncertainty might be permanent. Unless we make contact, unless we find definitive evidence of other intelligence, we'll never know for certain. The absence of evidence isn't evidence of absence, as the saying goes. It's just absence. We can accumulate negative results indefinitely without reaching definitive conclusions. The paradox persists because it might be unsolvable with our current approach. Yet we can't stop. The question matters too much. It touches everything about how we understand existence, consciousness, the future. Are we alone? The answer determines whether we're guardians of something precious or participants in something vast. It shapes our ethics, our long-term planning, our sense of cosmic responsibility. You can't just shrug and move on from questions that fundamental. Maybe the paradox resolves itself through time. We keep developing, keep advancing, keep expanding our capabilities. Eventually, we either find someone or become the someone others find. We either detect intelligence or become detectable. The waiting ends when the balance shifts, when our technology crosses whatever threshold separates invisible from visible. Or maybe it never resolves. Maybe the universe is structured so that intelligence remains isolated by default. Distances too vast, timescales too long, technological windows too narrow. Civilizations rise and fall, each alone in their corner of space, separated by gulfs too wide to bridge. They exist simultaneously but never simultaneously enough, missing each other by millions of years or thousands of light years, ships passing in the cosmic night. That possibility feels tragic. All this consciousness, all this awareness, all these minds contemplating existence, and none of them ever connecting. Each civilization asking the same questions, reaching the same conclusions, dying with the same uncertainties. The universe filled with solitary voices, speaking into darkness, receiving no reply. But tragedy requires an audience, requires someone to recognize the waste. If no one's listening, if no one's watching, is it tragic or simply neutral? The universe doesn't judge its own processes. It unfolds according to natural law, indifferent to whether consciousness connects or remains isolated. Our emotional response to cosmic loneliness says more about us than about the cosmos. What we're really confronting is existential discomfort. We evolved in social groups, surrounded by other minds, constantly communicating. Isolation feels wrong at a deep level. We're wired to seek connection, to find patterns, to imagine others exist even when evidence is scarce. The Fermi Paradox triggers those instincts, making us uncomfortable precisely because it suggests we might be fundamentally alone in ways our psychology can't easily process. Yet discomfort drives discovery. If we were comfortable with ignorance, we'd never search. The nagging uncertainty, the persistent questions, the inability to accept simple answers pushes us forward. We build bigger telescopes because the small ones didn't satisfy. We design new experiments because the old ones left gaps. Discomfort is productive when channeled properly. So where does this leave us? Still searching, still uncertain, still caught between possibilities we can't resolve. The paradox remains paradoxical. We have facts without understanding, observations without explanations, questions without answers. The universe is vast, old, and apparently empty of anyone we can detect. That reality conflicts with our expectations, and the conflict refuses to resolve cleanly. Human response to this situation reveals something important. We don't give up. We don't accept mystery as final. We keep pushing, keep questioning, keep searching, because that's what conscious beings do when confronted with fundamental unknowns. The Fermi Paradox might never be solved, but the attempt to solve it drives us toward capabilities we'd never develop otherwise. Perhaps that's the deeper answer hiding inside the paradox. The question itself matters more than any resolution. Searching forces us to become the kind of species capable of finding answers, regardless of what those answers turn out to be. We develop technology, refine methods, expand awareness, not because we know we'll succeed but because the attempt transforms us into something more capable than we were before. Consider what the search has already produced. Radio astronomy emerged partly from our desire to listen for signals. We built arrays spanning continents, synchronized observations across hemispheres, pushed sensitivity to levels that would have seemed impossible decades earlier. Those tools answered other questions too. Pulsars, quasars, cosmic microwave background, gravitational waves. Searching for intelligence gave us instruments that revealed the universe in ways we never anticipated. Space exploration follows similar logic. We sent probes beyond the solar system carrying messages for hypothetical finders. Those same probes mapped planets, measured magnetic fields, sampled solar wind, discovered moons we didn't know existed. The search justified the mission, but the mission delivered far more than we specifically sought. Voyager is still transmitting data from interstellar space, still teaching us about regions no human-made object had ever reached. Even our failures prove instructive. Every null result narrows the possibility space. Every frequency we monitor without detecting signals tells us something about where intelligence isn't or what methods don't work. Negative data feels unsatisfying, but it's still data. It shapes our models, refines our assumptions, guides future searches toward approaches we haven't tried yet. Science advances through elimination as much as confirmation. But there's a psychological weight to perpetual searching. Humans crave resolution. We want answers, not endless uncertainty. The paradox denies us that satisfaction, leaving us suspended between possibilities we can't confirm or eliminate. That suspension creates tension, and tension eventually demands release. Some people resolve it by choosing an answer and defending it aggressively. Others retreat into agnosticism, claiming the question is unanswerable. Both responses miss something essential. The productive stance lies in holding multiple possibilities simultaneously without collapsing into certainty prematurely. Intelligence might be rare. It might be common but hidden. It might exist but remain incompatible with contact. All these could be partially true in different regions or circumstances. The universe is large enough, complex enough, varied enough that simple universal answers probably don't apply. Reality resists reduction to single explanations when dealing with phenomena this vast. Think about how this connects to our species' broader trajectory. We're relatively young, technologically speaking. A few thousand years of civilization, a few hundred of industrial development, barely a century of spaceflight. On cosmic timescales, we're infants. Our current capabilities represent a snapshot, not a final state. What we can detect now differs enormously from what we'll detect in a century, assuming we survive and continue developing. That temporal dimension matters more than we usually acknowledge. If we're searching now, during our technological adolescence, of course we're not finding much. Our tools are crude, our methods limited, our understanding incomplete. We're like someone standing on a beach with a flashlight, trying to illuminate the entire ocean. The failure to see everything doesn't mean nothing's there. It means we're working with insufficient tools during an early phase of development. Projecting forward gets interesting. Assume humanity survives another 1,000 years without destroying itself or stagnating technologically. What could we detect then? Probably signals far weaker than anything currently accessible. Biosignatures in exoplanet atmospheres we can't yet analyze. Technosignatures we haven't imagined because our own technology hasn't reached that stage. The detection threshold drops as capability rises, revealing what was always present but previously invisible. Now flip that logic. If we're early in our development, other intelligences might be early in theirs. The galaxy could be filled with civilizations at our stage or earlier, all searching, none yet capable of detecting each other. We're all shouting into the darkness with voices too quiet to carry across the distances involved. The silence doesn't indicate absence. It indicates insufficient volume. Or maybe we're late. Maybe most civilizations rise and fall within windows that don't overlap with ours. We're examining ruins without recognizing them as such. Their signals degraded to noise, their structures decayed beyond recognition, their presence reduced to subtle anomalies in data we don't know how to interpret. Archaeology in space faces challenges terrestrial archaeology never encounters. No excavation possible, no carbon dating, no context beyond what electromagnetic radiation provides. Either scenario points toward the same conclusion. Timing matters enormously. The universe is old, civilizations are temporary, and the probability of synchronization is low. Two civilizations could exist in the same galaxy, both technological, both searching, and never overlap in ways that enable contact. Not because contact is impossible fundamentally, but because the coincidence required is statistically unlikely across the timescales involved. This reframes the paradox slightly. Instead of asking why we don't see anyone, ask why we'd expect to see anyone during this particular moment in cosmic history. The expectation might be what's wrong, not the observation. We're assuming contact should be easy, obvious, inevitable. But that assumption rests on intuitions formed in a human context where communication happens readily because we're surrounded by other communicators. Scale that up to galactic distances and timescales, and the intuition breaks down completely. There's also the question of what we'd recognize. Human technology produces specific signatures. Radio waves, optical signals, heat from energy consumption, chemical imbalances in atmospheres. We search for those because we know they exist, we understand their sources, we can detect them with current instruments. But technology evolves. What we use now differs from what we used a century ago. What we'll use in a century will differ again. Advanced civilizations might employ methods that leave no signatures we'd recognize. Maybe they communicate through channels we haven't discovered. Maybe their energy use is so efficient it produces no waste heat. Maybe they've moved beyond electromagnetic radiation entirely, using gravitational waves or quantum entanglement or something we don't have physics for yet. Our search assumes they're using technology similar to ours at a similar stage. That assumption could be completely wrong. Even biological assumptions might fail. We're searching for life as we understand it. Carbon-based, water-dependent, requiring certain temperature ranges and chemical conditions. That's the only template we have. But the universe might support other configurations entirely. Silicon-based chemistry in high-temperature environments. Ammonia as a solvent instead of water. Life emerging in conditions we'd consider completely hostile. If such life exists, would we recognize it? Would our instruments even register it as anomalous? The question expands beyond finding intelligence to finding life at all. We've barely begun surveying exoplanets. We've identified thousands but characterized only a handful in detail. The chemical analysis required to detect biosignatures is just becoming possible. We're at the very beginning of a process that will take decades or centuries to complete thoroughly. Making confident claims about life's prevalence when we've examined such a tiny fraction of available planets seems premature. Yet absence of evidence still weighs on us. Every planet we check and find barren, every star system we monitor and hear nothing, every analysis that shows no anomalies, it accumulates. The null results pile up, creating a pattern even if each individual result proves nothing. At some point, the accumulation of negative findings starts suggesting something real, even if we can't pinpoint exactly what. Maybe the suggestion is simply that defaults matter. The universe's default state is empty, non-living, unconscious. Life is the deviation, the exception, the unlikely outcome that occasionally emerges from chemistry when conditions align precisely. Intelligence is a further deviation, even less likely, emerging from life only under specific evolutionary pressures. Technology represents yet another level of improbability, requiring not just intelligence but specific types of intelligence with specific motivations in specific environments. Stack those improbabilities together and you get a filter so fine that almost nothing passes through. Not because any single step is impossible, but because the combined probability becomes vanishingly small. Earth might represent a winning lottery ticket, valuable precisely because most tickets lose. We exist not because existence is common but because someone has to win eventually, and we happen to be that someone in this region of space during this period of time. That perspective feels lonely, but it's also empowering. If we're rare, we matter more. Our choices carry greater weight because fewer consciousnesses exist to make choices at all. The responsibility to preserve what we have, to develop wisely, to avoid self-destruction, it intensifies when you realize there might not be backups. No other civilization will continue the experiment if we fail. The universe doesn't care whether consciousness persists, so consciousness has to care for itself. Still, loneliness isn't certainty. Rare doesn't mean unique. Even if intelligence emerges on only one planet per galaxy, there are hundreds of billions of galaxies. Even if civilizations last only briefly, the universe is old enough that many have already come and gone, many exist now, many will emerge later. The absolute numbers might still be large even if the percentages are tiny. We could be rare and still not alone, separated by distances and times that make contact nearly impossible but not actually alone in any absolute sense. Human minds struggle with scales this large. We can't really grasp what a billion years means for what a trillion stars implies. We compress it into metaphors and analogies that inevitably fail to capture the reality. Our intuitions formed in environments where everything was close, immediate, graspable. The cosmos operates at scales where intuition provides no guidance whatsoever. So we're left navigating uncertainty with limited tools, trying to answer questions that might not have clear answers at all. The search for extraterrestrial intelligence continues not because we know what we'll find, but because the question itself demands investigation. We point our instruments outward, we listen, we analyze, we theorize. And mostly, we find silence. That silence has textures though. It's not uniform emptiness. Some silences feel temporary, like we're just not listening correctly yet. Other silences feel heavier, more fundamental, suggesting deeper truths about how the universe actually works. The challenge is distinguishing between silences that mean not yet and silences that mean never. Consider the assumption that advanced civilizations would want to communicate. We've built that assumption into SETI since its inception. We scan for radio signals because we assume others would broadcast. We search for megastructures because we assume growth and expansion are universal goals. We look for waste heat because we assume energy use scales predictably with advancement. But these assumptions reflect human psychology projected outward. We're social, communicative, expansionist. We assume intelligence itself implies these traits because our intelligence has these traits. Yet intelligence could take radically different forms with entirely different motivations and behaviors. An advanced civilization might conclude that broadcasting is dangerous, that silence is survival. They might develop beyond physical expansion, finding fulfillment in virtual spaces or altered states of consciousness that require minimal resources. They might consider communication with primitive civilizations pointless or even unethical, preferring to let younger species develop without interference. They might exist on timescales so different from ours that our entire civilization rises and falls in what they consider an instant, making dialogue impossible even if both parties wanted it. Or maybe consciousness itself tends toward introversion at advanced stages. Early intelligence is outward-focused, exploring, expanding, consuming. But mature intelligence might turn inward, exploring consciousness itself, creating experiences and understanding rather than accumulating territory and resources. A civilization that perfected virtual reality or consciousness expansion might have no interest in the physical universe at all. They'd be invisible to our searches, not because they're hiding, but because they've moved beyond the domain we're searching. These possibilities don't make the silence less real, but they complicate what the silence actually means. Absence of detection doesn't necessarily equal absence of existence. It might just mean we're looking for the wrong things in the wrong ways at the wrong times. The temporal aspect particularly matters. Civilizations might exist for relatively brief periods. They emerge, develop technology, then either destroy themselves or transcend into states we wouldn't recognize. The window where they're both technological and detectable might be tiny. If that window averages a few thousand years, and civilizations are separated by millions of light years, the chances of two civilizations being detectable to each other simultaneously become incredibly small even if civilizations are relatively common. Imagine a forest where fireflies flash once every 1,000 years, each flash lasting only a second. Even if the forest is full of fireflies, you might never see two flash at the same time. The universe might be full of civilizations that never overlap in their detectable phases, ships passing in the night across cosmic timescales. This creates a strange possibility. Life might be common, intelligence might emerge frequently, technology might be a regular occurrence, yet contact remains impossible because the temporal windows never align. We'd be surrounded by evidence of past civilizations and future ones, but perpetually alone in our particular moment. The archaeological signatures would be there. Ancient megastructures, slowly decaying. Waste heat from civilizations that existed a billion years ago, now cooled and dispersed. Radio signals that passed through our region of space millennia before we developed receivers. The universe might be full of fossils from technological civilizations, but fossils don't communicate. And if we're thinking about fossils, we should consider what we'll leave behind. If humanity disappeared tomorrow, what traces would persist? Our radio signals will propagate outward for thousands of years before becoming undetectable against background noise. Our satellites will orbit for centuries before orbital decay brings them down. Our physical structures will erode, our materials will disperse, our chemical signatures will fade. Within a few million years, almost nothing would remain to indicate we existed at all. Maybe some odd isotope ratios in sediment layers. Perhaps some synthetic molecules that don't occur naturally. Traces of industrial activity in ice cores or rock strata. But nothing that would scream intelligent civilization to an alien archaeologist examining Earth millions of years later. If our traces fade that quickly, the same applies to others. Even if our galaxy has hosted thousands of technological civilizations, their evidence might be effectively invisible unless we happen to look at exactly the right place at exactly the right time with exactly the right instruments. The universe doesn't preserve evidence conveniently. This leads to an uncomfortable realization. The question, are we alone, might be fundamentally unanswerable with the methods available to us. We can search indefinitely and never reach certainty in either direction. Every negative result can be explained away as insufficient sensitivity, wrong targets, bad timing. Every potential positive result can be questioned as instrumental error, natural phenomena, or wishful interpretation. The scientific method prefers falsifiable hypotheses, but intelligent life exists elsewhere, sits in an awkward space. We can potentially confirm it with a single clear detection, but we can never definitively falsify it because we can never search everywhere at every wavelength across all time. The hypothesis remains perpetually open regardless of how long we search. That doesn't mean searching is pointless. Science proceeds through accumulated evidence even when individual experiments aren't conclusive. We narrow the parameter space, we refine our understanding, we eliminate possibilities. Each null result tells us something, even if it doesn't answer the ultimate question. We learn what intelligence doesn't do, what civilizations don't build, what signatures don't appear. The negative space gradually defines boundaries. And occasionally we find things that genuinely puzzle us. Fast radio bursts, unexplained energy signatures, odd chemical compositions in exoplanet atmospheres. Most of these resolve into natural phenomena once we understand them better. Pulsars seemed artificial when first detected. So did quasars. Both turned out to be natural, just unusual. But each mystery reminds us how much we don't know about what's possible in the universe. The gap between our knowledge and complete understanding remains vast. We've identified basic principles of physics, chemistry, biology. But the specific ways those principles combine under different conditions across billions of planets, we're barely beginning to explore that possibility space. Life might be common but unrecognizable. Intelligence might be everywhere but incomprehensible to us. Technology might surround us in forms we can't distinguish from nature. Our search operates under constraints we rarely acknowledge. We're looking for life like ours because that's the only template we have. We're searching for intelligence that thinks like us because we can't imagine alternatives concretely. We're expecting technology that follows similar developmental paths because our imagination is limited by our experience. But the universe doesn't care about our limitations. It operates according to physical law regardless of whether we understand or recognize the outcomes. If consciousness can emerge from silicon rather than carbon, we might miss it entirely. If intelligence can exist without technology, our searches won't detect it. If civilizations develop in ways we haven't imagined, they'll remain invisible to our current methods. This creates a methodological trap. We can only search for what we can imagine searching for. The truly alien, the genuinely different, the radically other might be undetectable not because it's hiding but because we lack the conceptual framework to recognize it. We're searching for keys under the streetlight because that's where the light is, even though we might have lost them in the darkness. Yet we persist because the alternative is giving up on one of humanity's deepest questions. We might be limited, biased, constrained by our own nature and understanding. But we're also capable of learning, adapting, expanding our search parameters as our knowledge grows. Each generation of instruments is more sensitive, each theoretical framework more sophisticated, each search strategy more comprehensive. The silence might break tomorrow or never. We might detect an unambiguous signal or continue finding nothing for centuries. Either outcome tells us something profound about the universe and our place in it. The search itself has value independent of the result because it pushes us to develop capabilities, ask better questions, understand more deeply what's possible and what isn't. Meanwhile, we exist in a universe that might be full of life or might be nearly empty. We don't know which, and our ignorance shapes everything about how we interpret our existence. The responsibility we feel, the meaning we construct, the choices we make about our future, all of it depends partly on whether we're alone or surrounded by others we simply haven't met yet. Perhaps that's why the question feels so urgent now. We're at a point in our own development where the choices we make could determine whether we survive long enough to become the kind of civilization we're searching for. Climate change, nuclear weapons, artificial intelligence, biotechnology. Each represents a potential filter, a test that civilizations must pass to continue existing. We don't know how many others have faced similar tests or what their success rate was. The timing matters. If intelligent life is common but short-lived, we might exist in a universe full of ruins. Civilizations that rose, flourished briefly, then destroyed themselves or were destroyed by circumstances beyond their control. Archaeological sites scattered across the galaxy, silent testaments to what was possible and what went wrong. We'd be living in a cosmic graveyard, surrounded by the remains of those who came before, unaware of the company we keep. Or maybe the pattern is different. Maybe civilizations that survive their dangerous adolescence become so advanced they're unrecognizable to us. They might exist in dimensions we can't perceive, manipulate reality in ways we classify as magic, or simply lose interest in physical space entirely. The universe could be teeming with post-biological superintelligences that regard us the way we regard bacteria, aware of our existence but not particularly interested in communication. Some researchers propose that advanced civilizations inevitably transition away from electromagnetic communication. Radio waves and laser signals might be training wheels, used briefly before moving to something more efficient we haven't discovered yet. Quantum entanglement communication, gravitational wave messaging, techniques that manipulate space-time directly. If that's true, we're listening on obsolete channels, waiting for messages that will never come because everyone else upgraded their technology millions of years ago. The zoo hypothesis suggests something more unsettling. What if they know we're here and are deliberately avoiding contact? Not out of hostility but from some kind of cosmic ethics, a prime directive that prohibits interfering with younger civilizations until they reach certain developmental milestones. We might be observed, studied, catalogued, but kept isolated for our own protection or their convenience. The universe could be full of watchers maintaining quarantine around Earth, waiting for us to demonstrate we're ready for contact. But ready how? What criteria would determine graduation from isolation? Nuclear disarmament? Unified planetary government? Solving climate change? Developing faster-than-light travel? The test might be something we can't even conceive of yet, a demonstration of maturity or capability we don't know we're supposed to be working toward. We could be failing an exam we don't know we're taking. The simulation hypothesis offers a different explanation entirely. If our reality is a constructed environment, the silence might be intentional design. Either we're the only conscious entities in a simulation built specifically for us, or the simulation is economically run, rendering distant civilizations only if we develop the capability to actually detect them. The universe might be less like a pre-existing place and more like a video game that loads new areas only when the player approaches. That feels unfalsifiable and therefore unsatisfying as an explanation. But it does highlight how our assumptions about reality shape our interpretations of evidence. We assume the universe is objective, consistent, governed by universal laws that apply everywhere. But what if it's not? What if the rules change in regions we haven't explored? What if consciousness itself plays a role in determining what exists and what doesn't? Quantum mechanics already suggests reality is stranger than our intuitions. Observation affects outcomes. Particles exist in superposition until measured. Entanglement connects distant objects in ways that seem to violate causality. If the universe operates according to principles this weird at quantum scales, who knows what other surprises await at cosmic scales we haven't properly investigated? Maybe the great silence is telling us something fundamental about the nature of existence itself. Not just that we're alone or that others are hiding, but that the universe doesn't work the way we think it does. Consciousness might be far rarer than matter. Intelligence might be an accident rather than an inevitability. Technology might hit absolute limits we haven't encountered yet. The path from single cells to spacefaring civilizations might be so improbable that it's happened only once in the observable universe. That possibility terrifies some people and comforts others. If we're unique, we carry enormous responsibility. Everything consciousness has achieved, everything intelligence has created, all of it depends on our survival. Lose humanity and you lose the only minds that ever asked these questions, the only eyes that ever looked up and wondered what else might be out there. The universe returns to unconscious physics, beautiful but meaningless, operating according to law but appreciated by no one. Alternatively, if we're common, our individual survival matters less cosmically. Other minds exist to ask the questions, other eyes to appreciate the beauty. We're part of a community even if we've never met our neighbors. The universe has backup plans. Consciousness will continue elsewhere even if we fail here. That's either reassuring or depressing depending on how you value human uniqueness. Both scenarios demand action but for different reasons. If we're alone, we must survive because there's no one else. If we're common, we must survive to eventually join the community of minds that's out there somewhere, waiting for us to figure out how to make contact or be worth contacting. The search continues regardless of philosophical implications. New telescopes scan more frequencies. Better algorithms process larger datasets. Theoretical frameworks expand to include possibilities we couldn't have imagined decades ago. We're getting better at this, more sophisticated in our thinking about what we're looking for and where to look. Mars rovers search for signs of ancient microbial life. Probes visit ocean moons in the outer solar system. Exoplanet surveys identify potentially habitable worlds in ever greater numbers. Each negative result narrows the parameter space, teaching us something about what life requires or where it's likely to emerge. We're mapping the possibility landscape even when we're not finding actual examples. The James Webb Space Telescope analyzes exoplanet atmospheres with unprecedented precision. We can detect chemical signatures that might indicate biological processes. Oxygen, methane, phosphine, combinations that suggest life rather than pure geology. We haven't found definitive biosignatures yet, but we're looking at dozens of worlds, and the catalog grows constantly. Each observation refines our understanding of what's normal and what would be genuinely anomalous. Ground-based radio telescope arrays continue scanning millions of star systems. The processing power available for signal analysis increases exponentially. We can now detect weaker signals across more frequencies simultaneously than ever before. If someone out there is broadcasting, we're more likely to hear them now than at any previous point in human history. But detection is only the first step. Interpretation comes next, and that might be harder. If we receive a signal, how do we know it's artificial rather than natural? How do we decode it if it's intentionally structured? How do we respond if response seems appropriate? These questions have been debated for decades without consensus because the scenario is entirely hypothetical. We're planning for a contingency that might never occur. The protocols exist anyway. International agreements about who speaks for Earth, how to verify a detection before announcing it publicly, what information should or shouldn't be included in any response. The fact that these protocols are taken seriously by governments and scientific institutions suggests we consider contact at least plausible, even if not imminent. Meanwhile, some people advocate actively transmitting rather than just listening. If everyone stays silent waiting for others to broadcast first, no one ever makes contact. Maybe we should be sending powerful, deliberately structured messages toward promising star systems, announcing our presence and hoping for response. Others argue this is dangerous, potentially attracting attention from hostile civilizations we'd be better off avoiding. That debate reveals our uncertainty about the universe's nature. Is it friendly, hostile, or indifferent? Are civilizations generally cooperative or competitive? Does advanced technology correlate with wisdom and ethics or just with power? We're projecting human psychology onto unknown aliens, which is probably unreliable, but we have nothing else to work with. Perhaps the silence is temporary. We've only been searching seriously for about 60 years. The galaxy is hundreds of thousands of light-years across. Even if civilizations are broadcasting, the signals might not have reached us yet. Even if they have, we might not have been looking in the right direction at the right time on the right frequency. Radio space is vast, and we've barely begun to explore it comprehensively. Or perhaps the silence is permanent, but not because we're alone. Communication might be impractical across interstellar distances. The time delays alone make conversation impossible, and the energy requirements for detectable signals might be prohibitive for most purposes. Civilizations might exist but remain isolated by physics, each developing independently, aware that others probably exist somewhere but unable to establish meaningful contact. We stand at a threshold ourselves. Our technology is advancing toward points that could change everything. Artificial intelligence might soon exceed human capability in ways that fundamentally alter what we are. Genetic engineering could redesign our biology. Space colonization could make us a multi-planet species. Each development changes the equation, shifts the parameters of what's possible and what we should be searching for. The Great Silence might resolve in our lifetime or remain mysterious for millennia. Either way, it shapes how we understand our existence. We're alone until proven otherwise, unique until we meet our cosmic neighbors, the only minds we know of in a universe vast beyond comprehension. That's both humbling and terrifying, a responsibility we didn't ask for but can't escape. What we do here matters because as far as we know, there's no one else to do it. The universe might be watching or completely indifferent, but either way, we're the only ones who can answer the question of what humanity becomes. The paradox persists because we keep expecting simple answers to questions that might not have them. We want to know if we're alone, but the universe doesn't organize itself around our need for clarity. It operates according to physical law, indifferent to whether conscious beings understand their place within it. Every search we conduct, every frequency we monitor, every planet we analyze adds another data point to an incomplete picture. We're building understanding incrementally, piece by piece, knowing we might never see the full image. That's frustrating but also honest. The universe doesn't owe us revelation on our preferred timeline. What we've learned is that the question itself transforms us. We develop capabilities we wouldn't otherwise need. We ask questions that push the boundaries of what we know. We confront our assumptions about life, intelligence, consciousness, and find them wanting. The search makes us better at searching, which might be the point. If we're alone, we're precious beyond measure. The only minds that ever looked up and wondered, the only consciousness that ever tried to understand. That demands we survive, that we choose wisely, that we protect what might be unique in all of existence. If we're surrounded by others we simply can't detect, we're humbled. Our technology is primitive, our understanding incomplete, our perspective limited by biology and history. We're children fumbling with basic tools, unaware of what operates just beyond our perception. Both possibilities require the same response. Keep searching. Keep learning. Keep pushing against the boundaries of knowledge because those boundaries are the only things we can actually move. The silence might break tomorrow with a signal that changes everything. Or it might persist for millennia while we slowly expand our capabilities until we become the civilization others eventually detect. Either way, we're here now, asking these questions, searching for answers that might not exist. That's what conscious beings do when confronted with mystery. We don't accept ignorance comfortably. We build instruments, design experiments, analyze data, and refuse to stop wondering. The universe might be full of life or nearly empty. We exist in that uncertainty, shaped by questions we can't yet answer, driven by curiosity we can't suppress. Somewhere out there, across distances we can barely conceptualize, others might be asking the same questions, feeling the same isolation, searching the same silence. Or we might be completely alone, the universe's single experiment with consciousness, speaking into a void that will never answer back. We don't know which. And that not knowing defines us as much as any answer ever could.